Welcome back, designers and developers. Let's make a ball and move it. Okay, so this is the second step of 10. We already know how to draw a ball, but we're going to define a drawing loop. So this is going to be kind of fun. We're going to keep constantly updating the canvas drawing on each frame. So we need to define a drawing function that will go over and over and over. So we can actually use a timing function, which is like an event, such as set interval or request animation frame. So let's get rid of everything besides the first two lines. So we'll keep our, we're going to get rid of this in our JavaScript file or in our script. We're just using HTML to write our JavaScript. And now we're going to define a drawing loop. All right, it's going to be fun. So the draw function will be executed within the set interval every 10 milliseconds. That's quick. Okay, so that makes sense though, right? We got to move those frames. So we're going to do a draw function. And let's open it up with our curly braces. And here's going to be our drawing code. Okay, and now we're going to say, well, how long do we draw? Like, what's the function there? And this is our input. Set interval is a method, an actual event method, and a function. Event handler, and its input is the timer handler. So the actual function that what we're going to be doing, and then how long in milliseconds. Cool. Okay. All right. So now we have it kind of set up, and then it's going to be called forever until we stop it. So let's draw the ball, and we're going to do this inside our function. So ctx begin path, right? And we always close the path. So I'm actually going to do this all at once. I mean, it is so easy to forget certain things. So I like to start and finish often. Let's just follow what they have. 50, 50, 10, 0, math dot. Let's see, when I say P, it actually tells me, no, you want to do pi, not power, right? I want to do pi. Okay, great. Times 2 for radians. And I don't need to put false, but I could if I wanted to. It doesn't matter which way it's going, okay? Because it's a circle. Okay, and then CTX, a fill style. And you can make it whatever color you want. I am going to make it purple again because I want to. And then close path. No. We have to fill it. Okay. Fill style is saying how it's going to look. And then the method, fill method, is saying actually fill it. Okay. This is what I want it to look like. Go ahead and fill it. All right, so all of that is going to happen at this particular place. Probably going to have to move it somehow. Let's see what's happening. Try your updated code. The ball should be repainted on every frame. Okay, cool. It looks like it doesn't really look like a ball to me. Interesting. Did I leave symbol 1, 2, 3, 4, 5? Okay. I don't know. I did it the same way, but it doesn't really look like a ball to me. Okay, moving on. Try your updated code. Making it move. You won't notice the ball being repainted, obviously, as it's not moving. So let's change that first. Instead of a hard-coded position, makes sense, we're going to define a starting point at the bottom center of the part of the canvas in variables called X and Y. And then we're going to, right, that makes sense. And then we're going to use those codes to define the position the circle is drawn in. Okay, that makes sense. So we're going to do another loop like kind of for, if, blah, 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 blah. Let's do this. So now we're going to add it above our drawing code. Okay, and so now we're gonna say we're gonna make it move. Okay, so actually I'm going to put that here, move that down here, find the drawing loop, make it move. Make it move is going to be let x. We want it to change, so we can't do constant. Canvas dot width divided by 2. Okay, so that's an expression. It's a property divided by 2. Canvas width is going to be an element. Width is going to be any, but since we're using it as a number, and then we're going to do let y equal canvas dot height. Oops. And that's, minus 30. Okay. Now we're going to update it. Instead of having 50-50, we're going to have x and y. Oof. Let's see. Now we have to do the important part. We want to add a small value to x and y after every frame to make it appear like the ball is moving. That makes sense? Okay, so d. So dx is like direction, dy is direction. Set their values to 2 and -2. Okay, so below our x and y, we're now going to define, we're going to define how much the ball moves. Okay, and then we're going to say let dx equal to, so it's going to move in that direction, and it's going to go up, apparently. Okay, so, and it's starting at the height minus 30. Interesting. Okay, so it's like going outside of the canvas, it sounds like. Let's see what that's going to look like. Equals 2, let dy equal -2. Okay, so the last thing to do is to update x and y with our dx and dy variable on every frame, so the ball will be painted in the new position on every, right, so it's like, this is where we have to do some sort of increment, right? Yeah, okay, here it is, So remember that concatenate, the little operation that says, okay, take that value x and then add this dx. It's like a simple way of, instead of saying x equals x plus dx, it's just, that's a simple way of saying that. We're going to throw that in our function. I'm going to call it increment. Increment the movement by saying x is now going to equal dx, and y is going to plus equal dy. Ooh, let's look at it. Yep, okay, let's see what happens. Look at that, it's drawing. Wow, that's neat. I like it. Okay. Okay, cool. Let's refresh it. Yeah, it is. Okay, so that's interesting. Now, it started at x, canvas width divided by 2 is here. Canvas height minus 30. The height is at minus 30. Oh, I see. Okay, that's cool. That's why it's starting down at the bottom. Okay, so save your code again and try it in your browser. Okay, yeah, it's leaving a line. Clearing the canvas before each frame. Ooh, it's leaving a trail because we're painting a new circle on every single frame without removing the previous one. Oh, there's a method to clear the canvas. Clear rectangle. Interesting. This method takes 4 parameters: the x and y coordinates at the top left corner of a rectangle and the xy coordinates of the... so it's going to be like the height of the canvas, the height and the width of the canvas. And so the whole area covered by this rectangle will be cleared. Add the following highlighted to the new line in the draw function. Okay, so we've incremented it, but now we got to clear it. So clear the canvas. Okay, and then, so now, Okay, where's it at? Oh, we want to do it at the beginning. Does it matter? Does it matter? Let's see. Let's just look. I'm going to put it here, and then I'm just going to see. Clear CTX dot clear. Probably, oh, if I do it down here, doesn't that mean it's going to, oh, it'll like, it won't run? Let's look. That'll be interesting. 0, 0. Makes sense. Canvas dot width. Canvas dot height. All right, we're saying the entire canvas. What was the X and Y? Let's see. I just want to see 4 parameters. The X and Y coordinates at the top left corner of the rectangle. Oh, yeah. So top left is always 0, 0. Makes sense. And then the bottom of the width. Okay, cool. So I think this is not going to work because I'm basically like clearing it every time. Yeah. Okay, let's check it out. Yeah, exactly. So I'm just clearing it. I'm clearing it. Okay, I just wanted to see that. And that has to do with code being read from top to bottom. So let's take this sucker out and let's put it here. And I'm going to call this, I'm going to clear the canvas before each iteration of the ball is drawn. Okay, that's what I'm doing there. There we go. Look at that. That's fun. Whee! Okay, cool. This is great. Cleaning up your code. Okay, we'll be adding more and more commands to the draw function in the next few articles, so it's good to keep it as simple and clean as possible. Let's start by moving the ball drawing code to a separate function. That makes sense? Okay, so instead of having this huge thing, this huge big draw function, let's simplify it. Okay, so the draw ball. Now we're gonna have draw ball first. Okay, so let's clean up our code. Clean the code. Make 2 functions. So the first one is this guy. Function draw ball. No input. Open up my curly braces, and now that is this whole thing. So it's right here. I don't increment it here. Okay, let's see. Okay, let's cut that out, put that here. Okay, all right, function draw is now simply, oh, I want to not clear the rectangle. I'm actually clearing the canvas in the okay, so now I'm breaking it up. Okay, I see. So now I'm calling, this is cool. Okay, so I'm going to call this draw ball function within my other function, right? So where does the draw ball happen? Well, the draw ball happens right after I clear the rectangle. So I clear the rectangle, then draw the ball, increment. Okay, this makes sense to me. Okay, now I'm going to call the draw ball to function. Okay, draw ball. Boom, it's right there. I have to make sure I put my parentheses so it knows that it's that function, right? If I don't have it, it's going to be undefined, and I'm going to get all sad and upset when I can't figure out why it's happening like that. Okay, so I still have this set interval. This is what's making it happen. If I don't have this, then it's not going to happen. So let's make sure that it's still working over here. Yep, it's still working. Great. Compare your code. We're good. We can change the speed. Okay, so I can make it draw every 10 milliseconds. Let's see. How about 100? That's going to make it really slow, right? Ball. Okay. Cool. All right. Let's make it 20. A little slower. Okay, there it goes. In this game, you know how it gets faster, right? It gets faster as it goes. That's fun. Okay, so different levels would have different speeds of the ball. Ooh, now we're going to make it bounce off the walls. Okay, so we're going to bounce off the walls. I just said that. Let's do it again. So let's go to next. Let's keep going. All right, third step. Here we are. It's nice to see our ball moving. Yes. Okay. Collision detection. This is cool. So we're going to have a simple collision detection. The collision will check whether the ball is touching or colliding with the wall. Right? Because we know the space of that, the end, of the rectangle. So we're going to change it. Cool. To make the calculations easier, let's define a variable called ball radius that will hold the radius of the drawn circle and be used for calculations. Add this to your code somewhere below the existing. Okay, so that makes sense. So we can actually, we can change it as much as we want. So in this arc, we're actually going to make it a variable, which is constant ball radius equals 10. All right, and then I'm going to change in here ball radius perfect in my function, my method to make a circle. Bouncing off the top, bouncing off the bottom. All right, now we get to use an if. Okay, so there's 4 walls, right? Rectangle. And our canvas, let's focus on the top one first. We need to check on every frame whether the ball, so if it's touching the top edge of the canvas. If yes, we'll reverse the ball movement so it will start to move in the opposite direction and stay within the visible boundaries, remembering that the coordinate system starts from the top left. Okay, so if y, all right, if y, so which one's the direction? Here. Okay, so if, do this, draw a ball. Okay, increment the movement. Where is the movement happening? The movement's happening up here. Okay, so here's the start. 2, -2. Okay, so X, all right. Canvas width, canvas height. Okay, cool. So I'm assuming so this is the one that's drawing, that's making the movement. Okay, so it's probably going to be in here. Let's see. All right, so if, I'm going to put it here, and then if y plus dy, so the direction, the new direction, it's always changing. Okay. Oh, no. Here, we have to do it after this. Yeah. Okay, hold on. So, if that, well, it's probably going to be up at the top of draw. Anyways, okay, sorry guys. I'm thinking inside my brain, and at this point, I'm not able to articulate it. So let's just keep going for now. And then we'll get to the articulation. All right, dy. So I'm saying the direction is now going to equal the negative. Oh, yeah, that makes sense. Okay, so, all right, if it's less than 0, which makes sense because we don't want it to be negative. We want it to go back down. Okay, so, and this would be y plus the equals, and then it's checking if this y plus this dy is less than 0, then instead we're making this dy now equal negative dy. Yeah. Okay, cool. That makes sense to me. All right, and then if the ball was moving upwards with a speed of 2 pixels per frame, now moving up with a speed of -2, which equals to moving down. Got it. Okay. So the code above would deal with the ball bouncing off the top edge. So now let's think about the bottom edge. So then we also have another if, and it's if y plus dy is greater than the canvas height, right? So then now it's going to be dy. It's the same thing. dy now equals negative dy. Remember that a negative is just reversing whatever sign that is, right? If it was negative, then negative makes a positive. If it was positive, a negative makes a negative. Okay, so it's just reversing. It's making it the opposite. So now it's saying that if the ball's y position is greater, right, greater, then we're going to say, so it's greater than 320. Oh, sorry, the height down here. Greater than 320 down here. Bye-bye. And it's going to bounce off. It's going to reverse the y-axis movement just as before. Okay, so we could remove these. Okay, great. So now we can, we can merge these, not remove them, right? So we use this cool little OR. Okay, we're going to take this, cut this out, use those 2 vertical lines, or this. Okay, then that's exactly what's going to happen, right? Because it's the same thing that's happening. Either way, we're going to have to deal with x the same way. Okay, so if, same thing, basically, guys, I'm just going to copy this sucker, paste it, and change this. X, dx, x, dx. Canvas, width now. X-axis is the width axis. And then X and X. Perfect. Okay, at this point, you should insert the above into the draw function just before the closing. Oh my gosh, I was right, you guys. Okay. I'm really proud of myself. So, we're checking to see if we have hit a wall in the canvas, and if so, we will reverse the direction of the ball. Okay, cool. Is it working? Let's see. I love it. Look at that. Oh my goodness. It's just not that hard, you guys. This is amazing. Okay, cool. All right, next. At this point, you should insert the ball. Okay, we did that. The ball keeps disappearing. Yeah, it does. So, okay, this is cool. This is math. I love math, you guys. You know I was a math teacher. I think I told you that. So this makes sense to me because let's go back and let's take a look up at the size of our ball, the radius. Okay, it's all the way, oops, my bad. Okay, it's all the way up here. So, I don't know why this is so far. Oh, because of my script. Okay, you know what? I'm gonna do a thing real quick. I'm gonna make this format my document. There we go. Okay. Brain. Okay, so back up here, where was it? We defined it. The ball radius of 10. Radius, remember, is like you start at 0 and you go out 10. So we actually have to compensate for that with a y. So the y would be like, oh, it's going to be like plus 10, minus 10, something like that. Or minus the ball radius, right? So let's take a look at that. I see that. This is because we're calculating the collision point of the wall at the center of the ball when we should doing it for the circumference. Okay, so yeah, exactly. So instead of just canvas width, we're going to go back down here. We're going to say, okay, minus the ball radius, right? So minus ball radius. Okay, now the reason why we're minusing the ball radius, okay, will reverse the direction of the ball. I'm going to add more comments in order to make sure that the ball does not appear to be going off the screen. We subtract the ball's radius. Perfect. Okay, cool. So here too, canvas, oops, with minus ball radius. Perfect. Let's look at it. Ba-da-boo. Yeah. Oops. Wait. Oh. Oh, hold on. Okay, so my plus, I have to add, hold on, I have to add something to X when it's on this side. It's here. It's like plus ball radius. Let's see. Hold on, my brain just. Oh, that makes sense. Yeah, plus ball radius. So wait, that makes sense. So when it's instead of 0, we're saying no, wait, the ball radius, so 10, right away. That makes sense. Okay. So instead, it's ball radius, and the 0 becomes ball radius, which would be the same as 0 plus ball radius, right? So, all right, here we go. Cool. Okay. I mean, I have my y first and then the x, but technically, you know, coordinate pairs. Let's actually put the x first because, you know what, every other place the x is first. And that's coordinate plane, right? The coordinate plane is always x, y. And then we have on all our other things x, y. So let's just do it like that for consistency purpose. All right, everybody, I had to pause this video because I really wanted to show you about try changing the color of the ball to a random color every time it hits the wall. And I hit a wall with that one. It was actually pretty dang challenging. So let me show you. First, I figured out how to generate a random color. You know, thank you, Chris Coyer, or however I say your name. And then I had to go in and, okay, so I started with wet ball color, right? I want to have a variable, and I'm going to change the variable down in this draw ball, right? So as I draw the ball, I always want the ball color to be random. Well, I had to do a function, right? And because I wanted it to be called, I wanted it to change. If I put the random color generator into just a variable, it's never going to change, right? So I have to call a function, and when I call the function, I have to make sure that it's when it hits. So what I was doing, like my big mistakes were I called the function. I was trying all sorts of places to call the function. I forgot, like obviously you put it in the if statement. If it hits this, right, and it changes direction, it also changes color. It calls that function again. But what I was doing, and I'll show you the right way, right? This is what it's doing. So it starts as black, and then it goes, and it changes every time it hits. Very cute, very cool. Okay, now obviously, I would want to, like, there's ways to choose just specific random colors. So I would want to make sure that I have a palette that is appealing, but this is cool. Next. Okay, so now we have to do the paddle and keyboard controls. Okay, let's check that out. So this is the 4th step. All right, we're going to define a paddle to hit the ball. So remember, the paddle is the little, rectangle. I can imagine that it has to be the same, right? It's going to just go across the x-axis, right? Well, the ball is bouncing all over the place. And so the x-axis is always going to be the same with that rectangle. So let's see what that's going to look like. Okay, so we need a paddle. Let's do that first. And of course, we're doing more variables up at the top. Okay, so first, let me start kind of putting in some. This is the getting the canvas that we are drawing on. And then setting it to 2D. Now this is drawing the ball, okay, or drawing ball. And now we're gonna draw the paddle, define variables for paddle. Cool. All right, and now, so let's do a constant of paddle height. We're going to make that pretty thin, and that's going to equal 10. And then we're going to do a constant paddle width equals 75. Make it bigger than the ball. Of course, the ball radius is 10, so we're going to have to make it like right there, So paddle X, there it is. So it's going to change. The paddle X, obviously, its X-axis is going to change with the canvas. It's always going to be canvas width minus paddle width. Well, this is the starting, right? This is the starting. It's starting in the very middle. Just like our ball is starting in the very middle. Okay, so there we go. This is the starting point. So, and now, after we draw the ball, we're going to draw here it is. So we have the, I'm going to put this over here. This is my random color. Okay, I don't have to have the random color unless I really want. Now I'm going to draw the paddle. Function, draw, paddle. Oops. Alright, doing something weird there. Close this guy. There we go. Function draw paddle. Notice none of my functions actually have input. You gotta use parameters when you do it all inside. CTX. Begin path. I am drawing this, starting it, ending, always CTX. End path, close path is always the last, and I remember that a method has to have parentheses. And now I'm going to make this rectangle. it's going to change. So I'm using variables, paddle x, right, because that's the starting value x. And then the y is the canvas height minus the paddle height. And then the width is the paddle width and the paddle height. Makes sense. The reason why we like to have numbers, why we want to have variables instead of numbers is because it also tells us what it's doing. So the canvas height, imagine, minus the paddle height. So remember, canvas height is, the bottom of the canvas. And then, so minus the paddle height, that makes it so that the paddle is going to be above the bottom of the canvas. Okay, we might actually change that a little bit. Paddle height, paddle width, paddle height, perfect. Okay, and then do I have a, no, I always close with my semicolon, even though it would work otherwise. Okay, and now I'm going to have the fill style. I'm going to have the fill style the same as the ball color. Let's see what happens with that. ctx.fill style equals, I don't know, let's see, ball color. I want to see what happens. I don't know. I don't know, guys. I haven't done this game before. This is fun. All right, and then finally, my close path. Silly guys. Thought I was being so clever by closing it up and then, messed it up there. I'm going to format my document real quick. There we go. Everything kind of, oh, look at that. Oh, I like that. They made it go vertically. That's cool. That actually makes sense to have that vertically. Just put it on its own little floor, own line. Okay, nice. Okay, so next. Now I'm allowing, ooh, this is crazy. I'm going to allow the user to control the paddle. So let's see right now what it's doing. There's no paddle yet. Well, we haven't drawn it. Draw ball. Did we draw the paddle? Why isn't it telling us to draw the paddle? Draw paddle. Let's see. There we go. Oh, it's not moving. That makes sense, right? I'm not making it move. I haven't done anything to make it move because none of this is actually defining the paddle. Cool. That's all right. So let's check it out. I like that it's changing colors every time. Okay, so now, right, so now I need a way to move it. So it should respond to the user's actions. It's time to implement some keyboard controls. Makes sense? So we're going to start with variables for storing information on whether the left or right control button is pressed. Right, left. So this is where WASD comes in, right? I don't know what we're going to do here. Let's check it out. Two functions handling the key down and key up events. The code. Okay, that makes sense. So the key down, key up, we just talked about these event listeners. So that's what we're going to do when we want the paddle to move left and right based on what the key is being pressed. Okay. Ba-ba-da-ba. Pressed buttons can be defined and initialized with Boolean variables like in this example. Add these lines somewhere near the rest of your variables. Okay, let's do that. Okay, so now I'm defining and initializing pressed buttons. It's a Boolean value. Okay, so first let write pressed equal false. So right now, the right isn't pressed. Nothing's pressed. Left pressed equal false. Okay. And then, yeah, they're not pressed. Now we have to listen for key presses. So we're going to set up 2 event listeners. So at some point, though, we are going to press something in order to make that paddle move. So add the following lines just above the set interval. Set intervals all the way down at the bottom. I don't need this anymore. Pretty sure. Let's see, there we go. Okay, it's still going, isn't it? That's great. Going forever. Okay, so now, let's see. We're going to do this add event listener. So we're doing the add event listener down at the bottom. Just above the set interval. So before we continue our draw loop, we're going to check, we're going to see, okay, are they keying up, are they keying down? And then based on that, then we're going to draw. Okay, so let's check that out. Document dot add event listener. Open this up, it's a method. Okay, it says type key of document event map listener. So it gives us all sorts of information. I love this. So we're saying key down, right? It even says key down, key press, key up. So we are doing key down and then key down and false. Okay. Keyword event, key down handler. Okay. All right. Do a semicolon. Now I'm doing another one. Document dot add event listener. Key up this document event, keyboard event, key up handler false. Okay. All right. So when the key down is fired on any of the keys on your keyboard when they're pressed, the key down handler function will be executed. Okay. All right. The same pattern is true. Oh, okay. I'm like, why is this here? I haven't done anything yet. The key down handler function will be executed. The same pattern is true for the second listener. Key up events will fire the key up handler function when the keys stop being pressed. Okay. All right. So add these to your code now below the add event listener lines. Okay. So now, let's see. So we are, I'm going to put in some comments here. The first will be fired so the first is when it's being pressed. The second is after it's done being pressed. Okay, so now let's make these actual functions. So, key functions. This is interval for, this is really how fast the ball is moving. Okay, the way it's drawn and moving. Okay, all right, so the key functions. Function. Key down handler, it's right here. Let's open it up. We're going to have an E. Okay, E. All right, and then open up our curly braces. Let's see, so if I'm going to have an else if statement. So the condition e.key equals right, or e.key equals arrow right. So is D the right? I don't know. Let's see. Okay, arrow right. And then we're going to say right pressed equals true. Okay. Oops. Okay, this is supposed to be there. This I need to get rid of. Okay. Here we go. All right, I had it a little weird. Okay. This is not normally there. Hold on a second. I wasn't paying attention. Okay, here we go. Right pressed equals true. Okay. Then else if, we're doing an else if condition e.key equals left, or e.key equals arrow left, then I opened up my function. That's not right. Else if condition. Okay. Yeah. And then okay, there we go. Let me get rid of this guy. There we go. Okay. Now, what happens? It's left pressed equals true. Okay. There we go. There we go. All right. This, I don't know why. Okay, whatever. All right, and then the next one is, okay, so we have the key down handler. Now we're going to do the key up handler. So function. Basically the same thing, y'all. So let's go ahead and let's actually copy all this, paste it, and now I'm going to call it the key up handler. And then if e key right, if e key arrow right, perfect, pressed is right, pressed is false, right? Because if it's now, if it's pressing right and it lets go, it's now false. And then right pressed false, left pressed true. I mean false. Okay. Okay, cool. Let's check this out. So basically, when we press a key down, this information is stored in a variable. That's going to be E. And then the relevant variable in each case is set to true. When the key is released, the variable is set back to false. Both functions take an event as a parameter represented by the E variable. From that, you can get useful information. The key holds the information about the key that was pressed. Most browsers use arrow right and arrow left, okay, for left-right cursor keys, but we also need to include right and left checks to support Edge browsers. If the left cursor is pressed, then the left pressed variable is set to true, and when it's released, the left pressed variable is set to false. Same pattern goes. Okay, all right. Okay, so we're understanding this. We still need to figure out E though. Are we like, yeah, okay. So the paddle moving logic. So we've set up the variables for storing the info about the press keys, event listeners, and relevant functions. Next, we'll get into the code to use all the things we just set up and to move the paddle on the screen. Inside the draw function, we will check if the left or right cursor keys are pressed when each frame is rendered. Okay, so up in draw, okay, we're going to check these functions, right? Makes sense. Let's go back up to draw. Here it is. Okay, so now in draw, we are going to check before it's rendered, when each frame is rendered. Okay, so if right pressed, paddle X plus and equals 7. Okay, so paddle X, that makes sense because the paddle X is the direction or the placement, right? The X. And so it's saying that when we press it, it's going to go 7. When we left press it, it's going to go -7. Interesting. Okay. So let's see, where do we put that? So we have the increment the movement. We draw the paddle here, so draw the paddle. So once we draw it, then we check. Let's see, if right pressed well, that's the true value, that's the value, right? True. If right pressed is true, then paddle X plus equals 7. So that's like the unit that we're going to move it if it's right. And then else if left press is true, then paddle X minus equals 7. So, right, minus would be going to the left. Makes sense. Okay. There we go. This currently works, but the paddle disappears off the edge when we hold. Oh, let's check it out, guys. Over here. Oh, look at this. Look at that. Look at that. Boom. Oh, it changed it. What happens if I do this? Nothing. Yeah, okay, cool. Okay. So, oh, and it goes away. Ah, come back. And it looks like it's actually changing, but it's not. Okay, cool. I think it'd actually be cool for it only to change when it hits the paddle of the color. Okay, random thoughts. All right, moving on. So we actually have to change the boundaries, right? That makes sense. That makes sense. We have to say when it needs to stop. So if right press, okay, so this is where we're getting into some fun math. We have paddle X equals the minimum, okay, math min, paddle X plus 7, comma, canvas width minus paddle width. Let's look at this, math min. I have to remember, math.min, JavaScript. It's a static method, returns the smallest number. Okay, so expects it out. Okay, so we're putting 2 values in for our math min, right? So we're saying, okay, we're going to choose paddle X is going to either be paddle X plus 7, if that's smaller, or it's going to be the canvas width minus the paddle width. Okay, so the canvas width minus the paddle width, okay, when that's small. So if that's at, let's set canvas width to 0 at the far left. Okay, so that's 0. I see. It's always going to be. Like if paddle x plus 7, so let's say the paddle x is 0, right? 0 plus 7, 7's always going to be bigger. So it's going to choose the canvas width minus paddle width. Okay, okay. And then the other one, of course, on the other side, then we're talking about the maximum, right? So we're saying, okay, paddle x. Oh, I was doing the wrong. Oh, okay. Paddle x, my bad. Paddle x is the maximum. Okay, so whatever's larger. So it's either 0 or paddle x minus 7. Okay. Whatever's larger. Okay. Because this would be negative. Okay, and then over here, whatever's smaller, because canvas width minus paddle width would be here, but paddle x plus 7 is way over here, so we want it this smaller. Okay, let's do it. All right, remember, we're doing this right in here because we're not copying and pasting. We don't copy and paste, okay? Let's just not. Okay, so paddle x equals math.min paddle x. Remember, I can use the same variable within my expression. I think a lot of people get confused with that, but that's algebra. Okay, paddle x, oops, stay inside there because I'm doing an expression. Paddle x plus 7, comma, canvas dot width minus paddle width. So whatever's smaller of the two, that will take the, okay, so let me put this in here. So, okay, so basically whatever is smaller of the two expressions. Okay, else if it's left pressed, now we're going to say, well, take the max of paddle x minus 7, comma 0. So whichever's bigger, okay? Cool. Now let's see. All right. So now, it's stopping. Okay, it's given some parameters. It's still acting like. So we still have to make it so that it only, like, it either, like, it doesn't hit the edge unless it's hitting the paddle, right? So I wonder if that's what we're gonna do now. Let's see. Okay, so now we kind of have a game, but it doesn't do anything. We're just like hitting it. So we are going to move on and we're going to make a game over. Okay, so it's fun to watch the ball bouncing off the walls. It is, right? There's nothing happening though, right? Like we don't have. Okay, sorry. Okay. So what we're going to do, let's try to implement the game over in our game. Here's a piece of code from the third lesson where the ball is bouncing off the walls. Okay, so here's, okay, here, bouncing off walls. I like that. If we have something like that, that helps us. So bouncing off the walls is here. So we've got this awesome little thing going on here. Okay, now we don't want to do that. We only want it to allow 3, left, top, and right. That makes sense. Hitting the bottom wall will end the game. We'll edit the second block the second if block. Okay, so it's if else. Okay. We'll edit the second block. So it's an if else that will trigger our game over state upon the ball colliding with the bottom edge of the canvas. For now, we'll keep it simple, showing an alert message and restarting the game by reloading the page. First, replace where you initially called the set interval with okay, so now we're actually changing. We're making this, okay, we're making this a constant interval equals set interval. Okay, and then replace the second if statement. Okay, let's see, if, second if, okay. So if y dy, okay, oh, we're not saying or, because look, we don't want it to hit the bottom. Got it. Okay, so we don't want it to hit the bottom. So only if y plus dy is less than the ball radius. It's not or. Okay, so now we're getting rid of this statement. No, we're actually cutting it. And we're going to cut it. Get rid of the or statement. So here, hold on. Okay. Now we're doing else. Else if. Paste that in here. Do you want, yep. Okay, open up. Alert. Game over. Okay. Game over. And then document dot location dot reload. This is an event. It's a reload function, built-in function. And then we're clearing the interval. Clear interval. Interval. That is why we needed that constant. Okay, so we need it for Chrome to end the game. Hey. Okay, cool. All right, here it is. Finally, we got to make a collision, right? We got to let the paddle hit the ball. Okay, the last thing to do is to create some kind of collision detection between the ball and the paddle so it can bounce off of it and get back into the playing area. Easiest thing to do is check whether the center of the ball is between the left and right edges. All right, so we're like, okay, is it here? And there we go. All right, so update the last bit of code you modified again and do the following. Okay, so now we're saying, okay, if, starting up here, we have this, okay. So if, as we're hitting, right, because this is as we're hitting the bottom, we have to find out if it's in there. Okay, so my random color is just sitting there. DDY, okay, we're still doing that. Else if y dy, canvas height minus ball radius, okay. Okay, we're doing another if. Okay, so we're testing it once we get to that bottom. Okay, and we're saying, okay, if now, if x, okay, if the x where we're at, our position, is greater than paddle x, which is the position of the paddle, plus or and, okay, if it's greater than paddle X, right? So the position of the paddle, which is the starting, and the ending position of the paddle, right? So and X is less than the paddle X plus the paddle width. Okay, so if X is greater than the paddle X, right, so the position of the ball, that's X, right? And then, so as long as X is between the start of the paddle and the end of the paddle, because the end of the paddle is the paddle X plus the width of the paddle, then keep going, right? Then keep going. Okay, then, yeah, let's do this. dy equals negative dy. dy equals negative dy. Okay, so okay, cool. All right, and then we're saying else if it's not in those parameters, now we alert the game is over. Okay, and then we reload, we clear the interval, we start the interval again. Boom. Let's see what happens here. Okay. Oh no, it's gone. Wait, what happened? Okay. If the so we need to check whether it hits the paddle too. Okay, compare. Hold on. Okay, my code is not working. Oh, look over here. What is that? What is that? Okay, let's see. Let me go in here and find out. Let's do inspect. Should show me what the problem is. Uncost and expected end of input 124. Okay. Oh. Okay. Yeah. Okay. So I have a problem. Where is it? There, okay. Function. So they put variable interval. Oh, they put var. And yet up there they put constant. Do you think that? No. But let's go ahead and do it anyways. Okay, so that's not it. This says that it's expected end. Let's see. Aha! Here it is. Draw. Okay, so function draw. Okay, here it is. Where does this belong to? Where does this one belong to? This one belongs to this. No, that's that. Else if this. Aha! I have one last missing curly brace. There it is. There it is. Okay, now let's check it out. I had this curly brace, and I finally found it by seeing that up here, this was red. Okay, now let's check it out. Okay, what happens? Game over. Okay. Reloads. Okay, cool. There we go. Alright. Pump, 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 pump. Yay! Look at that. What do you guys think about it? Oh, wow. This is great. Okay, cool. So, one of my favorite games of all time. But, hey, we don't have bricks. I want to have bricks. Let's do it. I bet we're going to build some bricks, and then every time it hits it. Amazing. Okay, let's keep going. I know it's a lot. Game over. Oh, come on. It has to be the center. Lame. Okay. All right, cool. This is good. All right, so next steps. We're doing great. Yes. Okay, and now we can lose, right? So we don't have the brick. We're going to build it. Brick field and